Okay, very good. I think we exceeded these 72 participants now. I believe you can see my screen very well, and you can see my laser pointer as well. So, yeah, thank you again for joining, and let's start the condition monitoring fundamentals free webinar today. Well, uh, good day, everyone. Uh, and welcome to today's webinar about the condition monitoring techniques fundamentals. First of all, I will be introducing myself. My name is Ali Attia, and I'm excited to guide you through the basics of condition monitoring. If any one of you is not specialized in condition monitoring, I think this webinar will make everything very easy and simple for him. So this session is designed for those who are new to the world of condition monitoring or simply want to understand better the techniques used to maintain the equipment reliability. So that's our goal in this webinar. So our goal in this webinar is to simplify as possible the fundamentals and basics and make those concepts of condition monitoring are very clear to everyone, even if you are not a condition monitoring professional. Okay, so here is what we are going to cover today. Um, First thing is an overview of maintenance strategies and condition-based maintenance, and then an introduction to the big five condition monitoring techniques, which are the backbone of the reliability program, and a closer understanding of the main techniques, which are vibration analysis, oil analysis, infrared thermography, ultrasound analysis, and motor current signature analysis. Okay, so usually by the end of this webinar, you will have a good understanding of the basics and the fundamentals of those techniques mentioned here, the big five, and their important role in the equipment reliability. So yeah, before I begin, I would like to briefly introduce myself for anyone who doesn't know me. This is Ali Atiyah. I'm a machinery condition monitoring engineer. I hold a mechanical engineering bachelor's degree, and I have the following certifications in condition monitoring. I'm certified vibration analyst category 4 from Mobius Institute and certified infrared thermographer category 3 from Infraspection Institute, and certified machinery lubrication analyst level 2, and certified maintenance and reliability professional and machinery lubrication engineer from the ICML, which is the International Council for Machinery Lubrication. Actually, I'm specialized in diagnosing the rotating machinery using wide range of techniques, including vibration measurement and analysis, oil sampling and analysis, thermal imaging, ultrasound, as well as performing on-site precision balancing and doing a laser alignment. My background experience, I've gained experience in mechanical maintenance and machinery condition monitoring across many different industries, including oil and gas, including cement industry, including steel and power generation, refineries, food and beverage. That's because mostly I was working in a service providing companies, which is providing a condition monitoring and machinery diagnostic services to different industries. Additionally, I've successfully delivered accredited trainings in both English and Arabic language online and the classroom to many professionals worldwide in Australia, in Egypt, in Saudi Arabia, in Oman, in Bahrain, and many other places. So yeah, that's it. That's me, and those are the couple of certification in vibration analysis, machinery lubrication, and thermography, turbo machinery, and certified maintenance and reliability professional. So yeah, thank you very much again for joining us. I think we are exceeding 70 participants now. I hope this webinar will be beneficial for all of you. So let's start with the first topic to discuss. The first topic we are going to discuss is the maintenance strategies and the condition-based maintenance basics. We are going to discuss some important definitions that should be known to everyone working in this field, working in maintenance field, in condition monitoring field, in reliability field. So by discussing this, we are going to be on the same page and we have a common language. Okay, so let's start with the very basic definitions, the maintenance itself. So what is the meaning of the maintenance, or what is the maintenance definition? So simply, there is many maintenance definitions, but this is a very simple definition that it is defined as a term that cover all the activities undertaken to keep the equipment in a particular condition or to return it to a such condition. So briefly, we can summarize the maintenance objectives in the following points. Mainly, we are doing maintenance to our equipment to maximize the production at a lower cost with the highest quality and the best safety practices, maximizing the equipment efficiency and reducing the scrap rate, minimizing the downtimes, the breakdowns, and the emergency shutdowns, minimizing the energy usage, and optimizing the resources we have, and optimizing the useful life of the equipment, optimizing spare part stock control, and so on. So maintenance actually can affect all of this. So those are the main objectives of maintenance action. So what are the types of maintenance or the different strategies of maintenance? Actually, I will be discussing or telling you the story of maintenance. So maintenance has an evolution story. So the maintenance strategies have evolved over the history to meet the changing demands of industries and progress in technology. With the continuous global market growth and competition increase, so the manufacturing industry was facing many challenges and desires to seek always a continuous improvement. So this effect is forcing the manufacturers to squeeze every asset for maximum value. So they are trying to squeeze all the assets they have for the maximum value, which means they need machines that are highly effective, flexible, and reliable. So this leads to the evolution of different maintenance strategies across the industry history. So let's start with the first maintenance strategy, which is the reactive maintenance strategy. This one was pre-1940s. Like the maintenance was mainly before 1940s, the maintenance was mainly reactive maintenance. What is the meaning of reactive maintenance? Simply, the reactive maintenance is focusing on fixing the equipment only after it broke down, only after failure. So we are not going to do any maintenance until the equipment fail. So that's why this maintenance strategy, they call it run to fail maintenance strategy. So this approach or this type of maintenance or this strategy of maintenance lead to a frequent downtimes and high repair costs. So at late 1940s to late 1970s, with the rise of the mechanization and the automation in industry, especially after the period of World War II, the industries adopted another strategy, which is the preventive maintenance strategy. This one, the second one. So what is the meaning of preventive maintenance strategy? This strategy involves a regular inspection, cleaning, and regular part replacement to prevent the equipment failure. So let's say that we know by experience that such equipment or such part is failing each 6 months. So we plan to make a replacement before those 6 months. Let's say 3 months or 4 monthly or 5 monthly, just before the equipment fail. So in that case, we can apply the preventive maintenance strategy. So we are trying to prevent the fail from happening. After that, at the early 1980s to the late 1990s, the progress in technology and sensors technology and so on, and computerizing everything, introduced the predictive maintenance strategy. The predictive maintenance strategy, which is the third one, it is where the equipment condition was always monitored using tools, using sensors, and techniques like vibration analysis, like infrared thermography, like oil analysis. And this allow the industry to predict the failure and act or taking a maintenance action before the failure occur. So we can say the predictive maintenance is the condition-based maintenance. We are not going to replace anything. We are not going to plan any corrective action before we check the condition of the machine, before we check the health of the machine. If the condition of the machine is bad, then we are going to plan for a corrective maintenance action. And starting from early 2000s to the present time, the modern strategy are the proactive approach, or the proactive maintenance, and the reliability centered maintenance. So mainly the reliability centered maintenance now is making use of the data of the predictive maintenance or the condition monitoring techniques in order to focus on identifying the root causes of failure and then eliminating the root causes of failure. So it is focusing on the root causes of failure. So we are studying the root causes, the main causes of failure, and we are trying to eliminate those causes of failure. So the reliability-centered maintenance combines a multiple maintenance strategies to improve the equipment performance, which means if you are going to apply the reliability-centered maintenance nowadays, it doesn't mean that all machinery should be covered with condition monitoring scope. And we will explain this in details in the upcoming slides. So today industry aim to integrate different condition monitoring techniques, and it aims to integrate maintenance with digital tools using the Internet of Things and AI, which is the artificial intelligence, and the data analytics for further enhancement of the efficiency and the reliability of the equipment. Okay, so this is the evolution of maintenance strategy, the historical point of view of the different maintenance strategies. Let's talk very quickly about each one of them. Starting from the reactive maintenance, for people who don't know what is the meaning of reactive maintenance, again, very simply, the definition is the maintenance that is performed after the failure take place in order to restore the equipment for its working condition. So you are not going to make any maintenance action before the failure done. So it's a run to failure strategy. So what are the corrective maintenance types? What the types of the corrective maintenance? Actually, any repairing is a corrective maintenance. Any overhauling is a corrective maintenance. Any rebuilding, servicing, all of this is considered as a corrective maintenance. What other names of the corrective maintenance? As you can see here, we can mention that the corrective maintenance is a reactive maintenance strategy, or a corrective maintenance strategy, or run to failure maintenance strategy, or breakdown maintenance strategy. All of those expressions give you one meaning, which is the reactive approach of maintenance. Okay? So what is the goal of the corrective maintenance or the reactive maintenance? The goal is As quickly as possible, you will repair or fix or replace the broken equipment to minimize the downtime of the production. Okay, so this is the goal of the corrective maintenance. So the actions here are repairing, replacing faulty parts, servicing, overhauling. All of these are the actions of corrective maintenance. This type of maintenance can save money for the non-critical equipment, where the breakdowns does not cause a very big problems. So it is not a bad type of maintenance or a bad approach. It works for the non-critical equipment. However, it can lead to a higher cost due to the unexpected repairs and the unexpected downtime and the possible damage to another parts of the machine. While it is useful in some situations, relying only on the corrective maintenance is not the ideal case or the ideal approach for the important equipment. Usually, a mixture of corrective, preventive, predictive maintenance is the best practice for keeping your machine reliable and reducing the overall costs. Okay. So yeah, this is the second type of maintenance, the preventive maintenance. So as a definition, what is the preventive maintenance? It is the maintenance which is scheduled according to a historical trends or experience. Okay, but you should know that there is a lot of guesswork is involved. It's just a guesswork from the experienced operators or maintenance personnel. So what are the other name of the preventive approach? We can say that this type of maintenance is the scheduled maintenance, is the routine maintenance. It is the time-based maintenance. Okay. So what is the goal of such maintenance? The goal of this maintenance is to prevent the unexpected breakdowns and extend the equipment lifetime. Before it happens, like before the failure happens, we are based on experience and some interpretations, some statistics, we will do the maintenance action at this date or after this running hours or so on. Okay. So what are the actions of the preventive maintenance? Any regular inspection is a preventive maintenance. Cleaning, lubrication, changing oil, replacing parts before they fail, all of this alignment, servicing, calibration, all of this is considered as a preventive maintenance approach. The advantage here, you can do a better planning, better control of the budget than the corrective maintenance approach, reducing of the collateral damage or the catastrophic failures. But the disadvantage are replacing a good condition parts. Maybe some parts could still work for 6 months, for 1 year, for 2 years, and you are replacing it now, which is introducing extra costs. Unnecessary work is done if you rely only on preventive maintenance strategy, largely based on a guesswork, as I told you before. And it could lead to maintenance induced failure as well. Okay, so this is the second type of maintenance, which is a time-based maintenance or preventive maintenance. This is just an example. This is an example of a simple, very simple preventive maintenance schedule. And a preventive maintenance schedule is like a plan, as you can see here. It's a plan to perform a regular checks and maintenance on equipment to keep it running smoothly as possible and avoid any unexpected breakdowns. As you can see here, here is pump 1, pump 2, pump 3, gearbox 1, gearbox 2, compressor 1, compressor 2, motor 1, 2, 3, and so on. So, and those are the times of week, and you can specify exactly the work plan in this table. As you can see, here is A and F. Let's see what A means. A means a visual check and lubrication check. F means clean. Okay, so you can assign a specific tasks, a preventive maintenance tasks or BMs, as most of people are using this expression. You can assign BMs for your assets, for your equipments, based on time. It's all based on time. So this is an example of the preventive maintenance schedule. Okay, now we are going to talk about the predictive maintenance. Predictive maintenance actually is the regular monitoring of the progression of any type of failure in your equipment. And then the machine repair, the corrective action or the maintenance action is scheduled before the catastrophic failure take place. So we are using a condition monitoring techniques to monitor this progression of failure. And then the machine repair is scheduled based on the condition of the machinery. Therefore, this maintenance strategy is called condition-based maintenance. Okay, so what are the advantages of condition-based maintenance? Of course, the reduction in maintenance cost, reduction in repair and overhaul time, reduction in spare parts inventory. But the disadvantage is it is expensive to implement because it needs tools. And those tools, you may purchase those tools in order to implement or apply the condition monitoring or condition-based maintenance. And it's not very easy to master the technologies. You need someone who understands vibration analysis, who understands infrared thermography analysis, who understands oil analysis and ultrasound analysis, and so on. So you need a skilled and trained, well-prepared personnel to apply this. Okay? So let's talk about the condition monitoring techniques. Yes, here in this slide, you can see those are the most of condition monitoring methods like vibration monitoring, thermography inspection, oil analysis, visual inspection, shock pulse method, and many other condition monitoring techniques. We are going to talk about the big 5 condition monitoring techniques within this webinar. So the big 5 we are going to discuss is the vibration analysis, thermal imaging, oil analysis, ultrasound testing, motor current analysis. Okay, so in this curve, as you can see here, this schematic diagram is for the B to F curve, which is potential to failure curve. Anyone who is working in maintenance, reliability, or condition monitoring will know this curve very well. This curve is very commonly used to show the progression of the defect or failure in equipment over the time. So this is the time axis and this is the machinery condition axis. Okay, it shows the timeline from the point where a defect here is detectable. The P point or the potential failure point is the point of detecting the failure, where the equipment actually starts to fail. But the F point here, it is the failure point or the functional failure point, which means that the machinery or the asset already fails. Okay, so the BF interval here represents the time available for maintenance teams to detect the failure condition or to detect the machine condition and fix or repair the issue using the condition monitoring techniques. So you cannot detect the failure progression unless you implement the condition monitoring techniques. You will never know that this machine is going to fail unless you implement a condition monitoring technique. So using condition monitoring or preventive actions to avoid a catastrophic failure, this is the condition-based maintenance. So again, by using techniques like vibration analysis, infrared thermography, oil analysis, and all the other, it can help in catching the issues early, reducing the maintenance cost, and increasing the equipment reliability, and gives you a proper time to plan for the proper maintenance action. Okay, so this is the 4th type of maintenance we are going to discuss today, which is the proactive approach of maintenance or the proactive maintenance. So what is the proactive maintenance is about? The proactive maintenance is about eliminating the root causes of the problem, the root causes of the failure. So all of this could be the symptoms of the failure. Symptoms of the failure may be high vibration, maybe emitting or increase in temperature, maybe any other problem you may notice or you may detect. However, all of this is just a symptoms for a problem, and there are a root causes of the problem. So in the proactive maintenance or the reliability centered maintenance, we are focusing in understanding the root causes of the problem, to dig deeper to find the root causes of the problem, and using this equipment, the condition monitoring techniques, we are going to study the failure modes that results in such problems, and we are going to eliminate the root causes of the problem. Okay? So this is the proactive approach or the reliability centered maintenance approach in a very brief sentences. Okay? So what is the advantages of such approach? It is less expensive strategy, less downtime, eliminate the causes of the root, of the failure, much greater uptime for your production. The only disadvantage is it is requiring a greater knowledge and understanding, and it is difficult to maintain the reliability centered maintenance program efficient by time. And of course, the reliability engineers specialized in this field can understand exactly how difficult this task is. Okay. So let's get back to the condition monitoring techniques, or sorry, the different maintenance strategies. To give you an explanation to understand each strategy and compare the strategies together, the human body is a great example to compare with the maintenance or the different maintenance strategies. As you can see here, this is the reactive maintenance. So the reactive maintenance, this is like visiting a doctor only when you are sick. You wait until something goes wrong and then you act to fix it. Okay, so this is just like the reactive maintenance. The preventive maintenance here, it is similar to taking a preventive medication or surgeries. You are doing preventive surgery or taking preventive medication to prevent yourself from getting sick or ill and so on, aiming mainly to avoid problems before they occur and keep the body in a good condition. Okay? The predictive maintenance could be compared or could be like monitoring your health with tools, such like a blood test, a wearable fitness tracker, or keeping an eye on any early warning for fatigue or pain and so on. So it helps to detect issues before they become a serious issues. Okay? The proactive maintenance approach, it is just like making a whole lifestyle changes to prevent the long-term issues. It is like quitting smoking, like reducing stress, like playing sports frequently, like having a diet control. All of this are focusing on solving the root causes of any health problem before it become an issue. So you are focusing on the root causes of the health problems and eliminating the root cause. So this is the proactive maintenance approach, or the reliability centered maintenance approach. Okay, so we usually monitor the condition of machines, and one of the most economical and basic means of condition monitoring is the visual inspection. So what is a visual inspection? Visual inspection is one of the earliest condition monitoring techniques employed by operators or by technicians. These techniques normally involve a daily walks around the machine by the operator or the technician to the equipment to observe any sign of deterioration, any sign of failure, any abnormal signs. These observations are critical, such as mechanical seal leaks or tubing leaks or external corrosion or coating deterioration and so on. In addition, the operator visual inspection covers the lubrication or the lubricating oil color, the lubricating oil foaming, mechanical seal buffer, casing surface hot spots or high temperature, any abnormal sound. So he is using all his senses to do so. So the expected information from the operator daily checks should include the following. He should be using smell for any odor or issues or overheating the equipment. His hear sensing for any abnormal noises such as knocking or rough sound from bearing and so on. Visual sense like leaks or any exhaust emissions and so on. He may use his hands to touch if he feels that there is an excessive heat or vibration and so on. So this is a very basic type of condition monitoring. However, the condition monitoring techniques serve as an extension and enhancement of human sensing, like vision and hearing and testing and smelling and touching. Those technologies, thermography, ultrasound, oil analysis, vibration, motor current signature analysis, and so on, helps the humans to gain more information about the machine and monitor the machinery health. Okay, so usually the condition monitoring techniques are like extension for your sight, extension for your hearing, extension for your touching, extension for spelling, and so on. Okay, so yes, this is the big five, the big condition monitoring techniques we are going to discuss today. Vibration analysis, lubrication analysis, ultrasound, thermography, and motor current signature analysis. The condition monitoring is a proactive approach to equipment maintenance that involve regular or systematic assessment of the machinery or of the health of the machinery. This is in order to detect or address any potential issues before they lead to failure. Several techniques are used in this process. Each technique offers a unique insights of equipment condition. Each technique has its own advantages and its own drawbacks. Integrating those techniques enables understanding the equipment condition, like the root causes of the failure, and enhancing the equipment reliability. Again, condition monitoring specialists or condition monitoring engineers or technicians are just like the human doctors, just like the machinery doctors. The role of machinery condition monitoring specialist is very similar to the human doctor role. So both are using suitable tools to diagnose and monitor the condition of what they take care of. If I'm taking care of this machine, I'm going to measure the vibration, check the ultrasound, take an oil sampling, do a thermography inspection, and so on. Okay. So there is one last question before we discuss the condition monitoring techniques in details. Are all the equipment in any industry and in any site should be covered with all the condition monitoring techniques? No. So since not all machines should be included in condition monitoring program, this analysis or this ranking, the asset criticality analysis, helps to decide the best condition monitoring techniques for different type of equipment. We have, let's say, 4 different type of equipment. The high criticality machines are the most important and need continuous monitoring, like installing an online vibration and oil monitoring systems to detect the problem in real time. As the criticality of asset started to decrease, the frequency of condition monitoring survey is adjusted accordingly. which means it's not very critical. So we are not going to install an online system. We are just going to measure this machine once each month or once each quarter and so on. Okay. So again, the frequency of condition monitoring techniques or survey is adjusted according to the asset criticality, with less frequent monitoring applied to a medium criticality assets. The low value assets or the low criticality machines are not included in the condition monitoring program because simply the cost of implementing condition monitoring program, the cost of monitoring is much higher than the cost of downtime or replacing the whole machine. So such machines are usually managed by fixing or replacing them only after they fail. So we implement the reactive maintenance strategy on such machinery. All right. So yes, this was the introduction of maintenance strategies and different condition monitoring techniques. And we are going now to discuss the vibration analysis introduction. If everything is okay so far, please sum up. I would appreciate that everyone is hearing me well, is seeing my screen, and everything is okay so far. All right, thank you very much. So yeah, okay, now we are going to talk about vibration analysis, an introduction about vibration analysis. So we are going to discuss some very important definitions to have a common language while discussing vibration analysis. Vibration analysis has been very interesting topic to many people actually. So let's simplify as possible this topic, starting from very basic questions. What is vibration motion? What is the vibration motion? The vibration motion, it is oscillating motion of a machine or machine component from its position of rest. The oscillating, as it happens here, the oscillating motion means a repetitive back and forth movement from its position of rest or the original position. So any movement going back and forth around a reference or position of rest, this motion is not a displacement motion. It's called vibration motion or vibrating motion around a specific reference, back and forth, back and forth. Okay, this motion or this vibration motion, we can understand the vibration motion, or we can study the vibration motion through the vibration signals. So the vibration motion always doing this sinusoidal wave or this sinusoidal signal. The vibration signal help us to understand how machines are moving if they are working properly. There are two very important characteristics of vibration motion, which is the amplitude of the motion and the frequency of the motion. The amplitude and the frequency. So what is the meaning of amplitude? Amplitude tell us how far and strong or how intense the vibration is. This is amplitude. So it describes how far a vibrating object move from its rest position during this oscillation motion or vibration motion. Okay? So what is the frequency? Frequency, very simply, it tells us how fast the vibration happen. How fast the vibration happen. So it measures how many times the machine parts move back and forth in a vibration motion in 1 second. In 1 second. So the frequency, it is always the number of complete cycles of vibration motion per unit time or in one time. There are some measurement for this frequency like the CPS, which is cycle per second, or Hertz, or cycle per minute, which is CPM, or revolution per minute, which is RPM. This is how we measure the frequency of vibration. So we have two parameters, two characteristics here, very important to keep in mind, and we will discuss later on why they are important to identify the vibration signal and what they indicate in the machinery. Okay, so very simply, by studying both amplitude and frequency, we can find the problems in machines early and fix them before they cause a bigger damage. Okay, so another question, very basic question. What makes the equipment vibrate? In rotating equipment, the vibration motion, as you can see here, is caused by exciting forces. What are the exciting force? It's like imbalance. The unbalance is exciting force. The misalignment is exciting force. The loose components are exciting force. There is a lot of different exciting forces for your machinery. The rotating equipment can be modeled in this figure below as a system. This is the rotating equipment. And there is system input, which is the exciting force, and system output, which is the vibration that we measure. So the vibration usually is the output of the exciting force for the system. Okay? Usually, we are measuring or the vibration motion happens in three directions: horizontal, vertical, and axial direction, 3D in the three dimensions. Okay, and it is characterized by properties like frequency, amplitude, and phase. We already discussed the frequency and amplitude. Such characteristics help in diagnosing the equipment issues. A lot of rotating equipment issues could be detected using vibration analysis method. Okay, third question is, why do we measure the vibration on machinery? Mainly to do three things. First is to monitor the machinery health condition and detect early failures or failure modes, and to assure the quality of any repair and to improve the equipment reliability. Those are the main goals of measuring vibration on equipment. Let's say we have equipment like this, a drive and coupling, gearbox, couple of bearings and pumps and so on. We are attaching our vibration accelerometers in a strategic places in order to gain more information about the vibration happening in this equipment, aiming to monitor the machinery health condition and detect early failures and so on. So what can the vibration monitoring detect? So measuring and trending the vibration of rotating equipment over time, it will allow you to indicate many problems, such as unbalance, misalignment, looseness, resonance problem, gearbox fault, bearing faults, electrical motor faults, pumps fault, fans, compressors, belt faults, and so on. So there is a lot of mechanical and some electrical defects that could be detected using vibration analysis technique. At this slide, we can see that those are the most common machinery faults that could be detected using vibration analysis technique. For people who doesn't have any idea about what could vibration analysis detect, it can detect unbalance, misalignment, looseness, pin shaft, bearing faults, gear faults, eccentricity, and much, much more. So very quickly, let's say the unbalance problem. The unbalance fault or problem, it happens when the center of the mass start to be away from the center of geometry of any rotor. So it starts to cause a driving force, a centrifugal force that wears out the machine very fast. So the vibration due to imbalance of a rotor is probably the most common machinery defect, one of the most common machinery defects. Misalignment as well. The misalignment is taking place when the center lines of the rotating equipment, two or more machinery shafts, are not in line with each other. So a misalignment take place, which is very destructive to the machine as well. Okay, and many other machinery faults could be detected using vibration analysis. Okay, so how does the vibration monitoring work? Simply, this is how the vibration monitoring works. In a very simple way, the vibration engineer or the vibration technician, so he measures the vibration on the machinery using a transducer. This transducer could be accelerometer, velocimeter, proximity probe. Anyway, he's going to use a sensor to measure the vibration in a specific measuring point of the machine. And he stores this signal in a data collector, a portable data collector or a stationary data collector. Anyway, he's going to save this data on data logger. The vibration data then is uploaded to a vibration software and should be analyzed by a skilled vibration analyst. If you are a certified vibration analyst category 2 or 3 or vibration analyst category 4, I think you should be responsible for analyzing the vibration data and the vibration different plots. Then the vibration analyst shall prepare a vibration analysis report outlining the machinery health with his findings and recommendations. Okay, so here we can see very simply the vibration data collector types. We have a portable data collector types and online systems. The portable types could be divided into two types, a vibration checker and vibration analyzer. The vibration checker is a very quick vibration on-site checking, and the vibration analyzer, it is the advanced one, the big one, the powerful data analyzer, which captures all the type of vibration data. And it is a portable a device that can move with you from one machine to another. The online system here, it is an online system installed in any critical machinery. The online condition monitoring system continuously and automatically monitor the important condition monitoring or condition parameters of the machine. And it usually gives you alerts before the problem turn into a failure or big problem take place. So very simply, how does the vibration data analysis work? Okay, for people who doesn't understand anything about the vibration analysis, this is very simple explanation which will give you an understanding of how does the vibration data analysis works from A to Z. So you should understand that the rotating equipment, let's say this is a rotating equipment, this is an electric motor coupled with a gearbox, okay? Each part of machine vibrates at its own specific frequency, vibrate at specific frequency, which means it's doing cycles of vibrations per second different than the other parts. This specific vibration frequencies depends on factors such as the machine type, such as the operating speed of the machine, such as the type of bearing used, and so on. When the vibration data is collected, as I explained before, from the machine, the vibration data analysis, it helps to identify if there are any problems by analyzing the vibration characteristics, which are the amplitude and the frequency. Okay, by analyzing the amplitude and the frequency of the vibration data, you can easily understand what's happening. So what is the importance of analyzing the frequency and amplitude? Frequencies are compared to a known defects, which means it is always associated with a common machine issues. We know that such issues are happening in the low frequency. Another issues like bearing defect happening in the mid frequency to a high frequency. The gear mesh problems are happening in high frequency and so on. Unbalance, it is in a low frequency or the running speed of the machine and so on. So we already know for people who are working as vibration analysts, they are analyzing the frequencies and refer each frequency or associate each frequency to a common machine issue. So what is the amplitude then? Why we are using the amplitude analysis? Actually, the amplitude of vibration at each frequency, like each frequency has its own amplitude, has its own height or amplitude. So the amplitude of vibration at each frequency reflects the amount of energy level of the machine vibration. And it can serve as indicator of the destructive forces acting on the machine. So very simply, the vibration frequency indicates the source of the problem, and the vibration amplitude indicates the severity of the problem. It can give you an idea if you have a problem or not from the frequency. At specific frequencies, we can say this is a bearing defect frequencies. If those bearing defect frequencies having high amplitude, which means the problem is severe. If they have low amplitude, which means that there is a problem, but it's not severe yet. Okay? So how can we know if the problem in any rotating machine is severe or not? That's why we are comparing the vibration severity, or we are using the vibration severity chart or the ISO, which refer to the International Standardization Organization, 10,816. So since there is always vibration out of any equipment, as you can see here, this is a normal machine, this is abnormal machine. Both are emitting vibration, both are vibrating. Okay? So since there is always a vibration out of any rotating equipment or out of any equipment, then setting a standard for vibration severity is very important to know if this equipment vibration levels are within the acceptable range or within the abnormal range. So the ISO 10816 is one of the fundamentals documents that states an assessment criteria for measuring and evaluating mechanical vibration. Of course, anyone is going to specialize in vibration analysis later on, or even take a vibration analysis course, he will understand more about the different classifications of machinery and different standards of vibration. As you can see here, these are the different frequencies, and there are many peaks on those frequencies. However, at this normal machinery, the peaks are still in the acceptable range. But in this abnormal machinery, there are peaks as well, but the peaks are very high, which means the amplitude is very high. The vibration amplitude is very high, which means that this is abnormal machinery according to the ISO standard level or range. Okay? So this is how the vibration analysis work. Finally, the vibration trend analysis is very important. Setting a vibration limit for each machine. As you can see here, there are 3 limits: acceptable limits, caution limit, and abnormal limit for each equipment as per the ISO standard, and the trending your machinery condition or machinery vibration level. This will allow you to assess the present conditions of rotating equipment and compare it against the previous condition and predict the equipment remaining lifetime as possible. Okay, so yes, this is the introduction of vibration analysis. Please let me know if everything is okay. Please thumb up if you don't have any problem with the voice or the screen. If everything is okay, Please let me know and sum up. All good? Perfect. Okay, thank you very much. All right. Let me remind you again, if you have any questions at the end of webinar, we are going to discuss those questions, or you can send me an email with all of your questions. If you can write down your question and send it to me over the email, I will be replying the email in the upcoming couple of days. Okay. Now we are going to talk about oil analysis or machinery lubrication analysis. What is the machine lubrication? Simply, let's ask the very basic question. What is the machine lubrication? First, we are going to discuss some important definition to have a common language while discussing oil analysis. So what is a machine lubrication? The machine lubrication, it is the science of reducing the friction between the rubbing parts. So we are reducing this friction between the rubbing parts using a suitable material, which is lubricating oil or lubricating grease. Okay? So what are the main function, or what is the lubrication doing? The main function of the lubricating oil. Usually, the main functions are as the following: friction control, wear control, corrosion control of machinery, temperature control of machinery, contamination control, and power transmission. So those are the main functions of lubricating oil. And of course, anyone who will be attending the course of machinery lubrication level 1, he will understand much more about the functions of the machinery lubrication. So again, why do we lubricate the machine? We lubricate the machine to reduce the friction between the rubbing parts in relative motion with each other, using a suitable type of lubrication. Okay? Okay, so that's why we need to study a specific science called tribology. What is the meaning of tribology? Actually, tribology comes from a Greek word called tripos, meaning rubbing, or to rub something, and the suffix ology means the study of. So it is, we can say that it is the study of rubbing things or things that rub. The first recorded tribologists in the human history are the ancient Egyptians. As you can see in this picture was found on the grave of Tahuti Hetep, an ancient Egyptian, indicates the concept of lubrication that was already used by the ancient Egyptians. As you can see here, the picture shows workers here dragging a large statue along sand or ground. As you can see, there is one man here pours a liquid, maybe an oil or water, as a lubricant to lubricate the surface, to reduce the friction between the sledge of the statue and the ground. Okay, so this is mainly the main function of using lubrication in any equipment. So let's talk about the oil analysis or the condition monitoring technique itself, the oil analysis technique. The oil analysis is one of the oldest predictive maintenance technologies still in use until today. This is a process of sampling the lubricating oil of machinery and analyzing it. It is like taking a medical blood test from any human being and getting it tested, where we can know about our diseases from our blood. So we can say that the lubricating oil is the blood of your machinery. The purpose of an oil analysis program is to verify that a lubricated machine is operating according to the expectations. So when any abnormal condition is identified through oil analysis, we should plan or may take an immediate action to correct the root causes of this condition. Okay, so usually the oil analysis is a routine activity, just like vibration analysis, for analyzing the oil health, oil contamination, and machine wear. The purpose of this program is to verify the lubricated machine is operating according to expectation. In order to understand the oil analysis program, you should go through the following topics. You should understand sampling procedures, selection of tests, oil analysis methods, and report or oil analysis report interpretation. All right, okay. So, just one moment. Okay. Yes, in this slide, we are going to talk about the types of oil analysis, the different types of oil analysis. We have 4 different types of oil analysis. First one is the online oil monitoring. The online oil monitoring, it's a real-time sensor, just like this sensor, continuously tracking the oil quality and detect any anomalies, any exceptions without doing any manual sampling. So it is 24/7 monitoring, 24/7 monitoring for the oil condition. And of course, such solutions are implemented for the high criticality equipment. The other one is the field inspection or on-site analysis. The field inspection, it is like a visual inspection, like a daily visual inspection of side glasses and magnetic plugs and so on. The third one is the portable field instruments or the portable field tests, portable field oil analysis tests. It's a very quick and simple test performed on site at the equipment location without any sampling or bottle sampling. This could be a very quick test, giving you a quick information that you need to know. However, it's not very deep type of oil analysis or complete solution to understand everything about the condition of the oil. The one which is most commonly done or used is the laboratory oil analysis, which means that you are sampling the oil bottles or oil sampling bottles are taken and sent to a specialized laboratories to measure the wear metals, to measure the additives of the oil, the contaminations of the oil, the health of the oil itself, if there is any oil degradation or something. Okay? So each method of those has its own advantage and it's used based on the criticality of the equipment. Usually, integrating those methods are good and ensuring a comprehensive lubrication program or lubrication health monitoring program. Okay, so oil analysis is used to define 3 basic machine conditions. That's why we are saying that oil analysis is 3 categories or 3 different types. The first type is the fluid properties analysis. We are doing oil analysis to test the physical and chemical properties of the oil itself, to know the condition of the oil itself. Okay? And the second one is the contamination condition oil analysis, which are tests done to know the lubrication system cleanliness levels, if there is any water contamination, any solid contamination, and so on. And the third type or the third category of oil analysis, it's called wear debris analysis. We are doing this wear debris analysis to know the machine parts conditions. Okay, so to know the machine part condition by analyzing the wear particles in the lubricant, and machine could be evaluated, machine wear could be evaluated and quantified to know exactly the machine surfaces conditions. So this is a summary of the different oil analysis tests We can do oil viscosity test. It measures the lubricant resistance to flow. We can do a total acid number test or TAN test. We can do the FTIR test, which is a Fourier transform infrared spectroscopy test. We can do a particle counting test to know the size and the quantity of particles in the lubricant. We can do the very famous Carl Fisher test to know the water content, or the water test to know the water content in the lubricant. Each one of them measures a specific property, or measure a specific thing we need to know, or a specific issue, maybe an issue we need to know about the oil or the machine, and each one has its own purpose. We can do as well elemental analysis. We can do ICP spectroscopy. We can do a direct read ferrography, analytical ferrography, and so on. So those are the most commonly used oil analysis different tests. It is just overview for those tests. Of course, anyone who is going to deeply study or take courses in machinery lubrication analysis, those topics are going to be discussed in details. Okay, so the last thing we are going to discuss about oil analysis program is the oil analysis program implementation. It is just like the vibration analysis. You need to have a baseline and put a caution level and the critical level for your different analysis. In the implementation phase of condition monitoring system, the analysis must be made frequently, like at least every 3 months. But even better if you can do this once per month in order to establish a trend. Trend is very important in condition monitoring. Trend in vibration analysis is very important. In infrared thermography is very important. In oil analysis is very important, and so on. So we are always saying that trend is your friend in condition monitoring. As useful trend consists of minimum 5 progressive samples taking from the same oil system under the same operating conditions. Before establishing a trend, it's important to have a baseline, as you can see here. This is a baseline. This is a very good condition. A baseline sample of the fresh new oil. This will be used as reference later on for verifying anything, like, for example, the additive package, if it's still intact, or verifying the contamination levels, and so on. Every oil system should have a log, like this one, a log book, where the analysis results are registered. Nowadays, there are a lot of software that can register the oil analysis results and reportings, and it should contain information about the oil type and so on. Okay, so yeah, this is the oil analysis technique. This was the second most important technique in condition monitoring. Now we are going to talk about the infrared thermography technique. If everything is clear, please sum up. Let me know everything's clear. The screen is good. Everything is okay so far. You can hear me well? Okay, perfect. That's great. Okay. So yeah, now we are going to discuss the infrared thermography briefly in a very simple way. What is infrared thermography? Infrared thermography, it is a method. It is a condition monitoring technique. It is a method of inspecting electrical and mechanical equipment by obtaining the heat distribution picture and analyzing the thermal pattern. This inspection method is based on the fact that most components, most electrical components, most mechanical components in any system shows an increase, most of time, an increase in temperature while malfunctioning. When there is a problem, so it shows increase in temperature. It emits more infrared radiations. So the technique of infrared thermography is a technique for converting this infrared radiations, which are invisible to our eyes, into a visible picture. Okay, this is an example of electrical equipment inspection. This is an example of mechanical equipment inspection, and this is an example of piping and valves and maybe steam traps inspections. Okay, so very simply, what is the infrared radiation? This very basic question has a simple answer. The infrared energy, it is a heat energy in the form of electromagnetic waves. This is the infrared energy or the infrared radiation. The infrared energy moves at the speed of light and can pass through the atmosphere or vacuum. With infrared radiation, heat can transfer and take place without any contact. Because infrared wavelengths are longer than the visible light, they are invisible to our human eye. As you can see here, the range of infrared radiation is below the visible range. So this is a visible range, starting from 0.4 microns to 0.7 or 0.8 microns maximum. And the infrared radiation is all or anything below the visible eye. So we cannot see the infrared radiations with our bare eyes. That's why we are using the thermography camera to convert the infrared radiation into a visible images. In this graphic, you can see here, we have this diagram and we have this narrow portion of electromagnetic spectrum beginning at the left with the graphic and moving to the right. We have indicated or included the gamma rays, X-rays, ultraviolet rays, visible light or visible rays, the infrared rays or the infrared radiations, microwave radiations, radio radiation, and so on. Okay? So the third question is, what is the infrared thermography? The application of thermography, it is very simple that the thermography can be applied to any situation where the knowledge of the thermal pattern across any surface providing a meaningful data about the structure or meaningful data about the process or meaningful data about the system itself. Okay? So the theory behind using infrared thermography is very simple. All the objects in this planet Earth, all the objects above 0 Kelvin, 0 Kelvin, which is equal to negative 273 Celsius. So all the objects above 0 Kelvin emit infrared radiations. And the infrared energy could be captured by the thermal camera and be converted to a visible images that we can see. Okay? So while this heat energy is invisible to a human eyes, the camera still can detect and convert the emitted infrared energy into a visible image. Even the objects that human thinks of being very cold, such as snow or ice, it produces heat. It's still producing heat. Okay, so anything above 0 Kelvin still producing heat, even if you are talking about a snow, you are talking about ice. With the thermal imaging, the humans are able to push back the limitation of their eyes or their sight and extend the senses of their sight. In doing this, we gain a new set of capabilities that allow us to gather information about the structure or object or any system. Okay, so what makes the thermography technique as a condition monitoring technique is very useful? Three main things. First, it's non-contact. You don't need at all to contact any machinery or any equipment. So it's non-contact and use remote sensing, which means it keeps the user or the thermography or the thermographer away or out of danger. And it does not affect the target at all. Okay? And the second thing is it is two-dimensional which means it is possible to make comparison between areas and targets, different areas and different targets. The image allow for an excellent overview of the target. Not like the thermal gun, for example. The thermal gun can provide you the temperature at one point. However, the thermal camera can give you unlimited points of temperatures. So the image allow for an excellent overview of the target. The thermal pattern across the target can be visualized and saved on a software for analysis. Okay. And the third benefit is it is a real-time technique, which means it enables a very fast scanning of stationary targets. It enables capturing fast-moving targets. It enables capturing fast-changing thermal patterns and so on. Okay, so let's talk about the applications of thermography. Thermography could be used in a lot of applications. First, in condition monitoring and predictive and safety applications, like we can inspect electrical equipment, rotating equipment, stationary equipment, fluid systems, and many other equipments. We can use it in quality control and the production monitoring, in medical applications, just like the thermal cameras used in 2020, the COVID-19 era, and research and development. It could be used in security system and a lot of military applications and firefighting and so on. Now we are going to focus on the condition monitoring applications of the infrared thermography. So thermal imaging can predict the electrical failures before it become fire, before it becomes a big problem. So the electrical problems that could be detected, or evidences of defects that could be detected by thermography, includes loose connection, deteriorated connections, overloaded circuits, unbalanced loads, open circuits, indicative heating, high resistance, corroded connections, many other defective electricity transmission equipments could be detected using infrared thermography. Each of these type of defects and how to differentiate between them, it's usually covered in infrared thermography category 1, category 2, and the category 3 courses. Second type of applications that we can use the infrared thermography in is the mechanical problems. We can detect many faults using infrared thermography. Shaft and pulley misalignment, bearing faults, bad lubrication, if you have an over lubrication problems, under lubrication problems, belt wear, tension problems, all of those different problems could be detected using infrared thermography. The mechanical fault will cause the following. Of course, we know that the mechanical faults could decrease the reliability and efficiency of machine, increase the power consumption, increase the rate of downtime, increase the spare part consumption rate, production loss, bad quality of the production, unsafe production operation, and so on. So it's unlimited disadvantages or results of mechanical faults that could be prevented and detected using infrared thermography. Okay, so third type of applications is furnaces and boilers application faults. So in order to detect faults in very high temperature applications like furnaces or boilers, you may utilize the infrared thermography to do so. We have many faults that results in a loss of heat energy. The damaged or bad insulation could be detected using infrared thermography. The bad heat distribution as well. The internal or potential blockage, the internal tube blockage could be detected using infrared thermography. Okay. In fluid systems as well. So the fluid flow application faults and effect. As you can see, I'm always presenting a couple of digital photos and thermogram photos to give you an imagination for what what are the capabilities of infrared thermography camera? You can detect fluid flow problems, yes, like the damaged insulation, like the leaking pipes and valves, internal pipe blockages, and so on. Okay, so this was the fourth type of applications that could be inspected and detected using infrared thermography. You can use infrared thermography in quality control and production monitoring. As you can see here, this is a paper or a pulp and paper industry. We can still detect the quality of the product using infrared thermography. Infrared thermography is very important for quality control in many industries like steel production, aluminum production, pulp and paper, ceramic, chemicals, and so on. We can use the infrared thermography as well in optical gas imaging. It is the most effective solution for many industries or many industry safety by detecting the gas leaks for a huge number of pipes or tubes, furnaces, boilers, compressors, valves, and many others. So the optical gas imaging is simply imaging and viewing of the invisible gases to let you see those gases and identify where exactly the leak is. So this is a special type of thermal imaging that is used mainly for gas imaging. Now we have finished all the applications and the theory behind using infrared thermography. Please let me know if everything is clear. Please sum up. Let me know if everything is okay so far. You're happy. You feel okay. The camera is good. The voice is good as well. Please let me know. All right, perfect. Okay, thank you very much. Now we are going to talk about the ultrasound analysis. The ultrasound is one of the condition monitoring techniques. Ultrasound is one of important condition monitoring techniques. So let's start with the basic questions. What is ultrasound? The ultrasound is a sound waves that have a frequency level above 2 or 20 kilohertz. So the sound waves in this frequency or in this frequency spectrum are higher than what we can normally hear by our human ears. So that's why it's called ultrasound. So this is the audible frequency or the audible range. This is the infrasound and this is the ultrasound. So ultrasound basically means above our hearing range, above our hearing range. It can detect or many sounds or many sources can lead to ultrasounds, just like turbulence, just like friction, impacts, arcing in electrical equipment, faults on rotating machinery or electrical systems or air or steam systems. All of those are generating very high frequencies above our audible range. In order to hear them, we need a device. This device is called ultrasound probe. So we are using the ultrasound probe in order to detect or catch those ultrasound waves and start to analyze it in order to monitor the condition of our equipment. So what is the ultrasound analysis? The ultrasound analysis, it is a condition monitoring technique that uses the high frequency sound, the ultrasound, typically any sounds above 20 kilohertz to detect mechanical or electrical and fluid related issues in machinery and systems. There are two modes of ultrasound detection: the airborne ultrasound detection probes and the direct contact probes. So this contact should be directly, this probe should be directly in contact with machinery or the object you are inspecting. And this probe could detect the ultrasounds, the airborne ultrasounds. So again, what is the theory behind using ultrasound analysis? Most of rotating equipment and many fluid systems conditions, it will emit sound pattern in the ultrasonic frequency of the spectrum. So changes in this ultrasonic wave emissions, it can reflect the equipment condition. As you can see here, this operator wears a headphone and listens to the sound. And he has a device that he can record the data. Many of the faults being detected, just a moment. All right. Many of the faults being detected using or based on a qualitative techniques like comparing and the trending, comparing the different sounds and the previous sounds and the trending the sounds and so on. So therefore, it takes some time to become familiar with such tools. The instrument itself or the device or the ultrasound device itself, it also display the amplitude, which can be used as a gauge to check how loud it is and whether it is changing since the last measurement or not. So you can trend the ultrasound. Okay, so what are the different applications of ultrasound testing? There are a lot of applications. We can summarize those applications in some mechanical applications and electrical application inspection. The mechanical application inspection could be divided into rotating equipment inspection, valves inspection, fluid system leaks detection, and so on. We can detect the bearing condition monitoring, bearings condition monitoring, or bearing condition using ultrasound. The condition-based lubrication, we can use ultrasound. The cavitation effect in pump, the conveyor belt systems, all of this could be detected using ultrasound technique. Any valve inspection, the valve leak detection, the steam trap inspection, we could use the ultrasound. Fluid systems like compressed air systems or compressed gas systems or heat exchangers or tanks and boilers, all of this could be detected, or faults in such systems could be detected using ultrasound technique. The electrical applications, which are the strongest, one of the strongest techniques to detect faults in electrical applications, it can detect tracking or arcing or corona. It can detect switchgear or power lines and insulators. It can detect faults in transformers, in circuit breakers, and so on. Okay, so the ultrasonic detectors in general can be used to identify problems related to component wear as well as fluid leaks, vacuum leaks, steam traps failures, and so on. A compressed gas or fluid forced through a small opening or leaking through a small opening creates turbulence with a very strong ultrasound that could be detected using the ultrasound probes. Even though such leak may not be audible to the human ear, the ultrasound probe still detect such sounds. So the specific sound quality of each type of emission is heard in the headphones, while the signal can be observed on this device or this meter, which allow a quantification of the signal. So you can quantify the signal, you can save the signal, you can trend the signal and compare it with the previous signals. Okay. So yes, this is an introduction to the ultrasound. And finally, we are going to give an introduction for the fifth most commonly used condition monitoring technique, which is a motor signature analysis. And simply, the motor signature analysis acquires the motor current and analyzing it, acquires the motor current and the voltage signal without any interruption in production, and analyzing the drive signals to identify many different types of faults The data can be acquired from the motor control panel and enabling an easy testing of remote, inaccessible, or maybe hazards areas of motors. So the detectable fault conditions using motor current signature analysis, any torque ripple, any harmonic, you can do a harmonic analysis, any rotor bar defect or condition, any insulation defect, any wrong connection or motor lamination faults, winding short circuits, open coils, each and every electrical fault may be happening in electrical motors could be detected using the motor current signature analysis, as well as many mechanically related problems can be diagnosed using these motor analysis techniques. So again, the top benefits of the motor current signature analysis is improving the reliability and the cost reduction, which means you can do an early fault detection using motor current signature analysis. You can improve the performance of your motors, a better informed maintenance and repair decisions based on the data you acquire from the motor current signature analysis. It is cost effective and increase the efficiency of your equipment and your maintenance action, reduce the downtime of your production and reduce the maintenance cost, as well as improving the safety. So yes, we came to an end with our webinar today. I'm very happy to have all of you today. I know we are, I think, a bit late, maybe 15 minutes extra. I hope it was not boring for anyone. Everyone enjoyed the webinar and it was beneficial to everyone. Yes, please, you can follow the LinkedIn page, which is Condition Monitoring Skills, and subscribe the YouTube channel. I usually upload a couple of different videos about condition monitoring. The channel is called Condition Monitoring Simplified, and you can follow me on LinkedIn. My name is Ali Attia. For any technical questions or any specific inquiries, this is my email here, ali@cmstechnical.com. And for the attendance certification, please send your name you want on certification to this email, info@cmstechnical.com. I'm reading the messages now.